Okay, so two characteristics of a metal. There's a huge list here. I'm going to pick just a couple. So we can say they have high melting points. We can also say that metals are typically shiny. You could have had malleable, ductile, they're strong. There's a list, but you just need two key things there. Okay. Um, which acids are used to make chloride salts? So the acid that we would use is hydrochloric acid, and that's the chloric bit that gives you the chloride salt. Test for hydrogen. So what we have to do is we put a lighted splint into the gas, and if it's hydrogen, it will burn with a squeaky pop. So it's the squeaky pop test. You can't say just squeaky pop test. You have to explain it as we've done here, saying it'll burn with a squeaky pop. Okay, nickel's a metal. How does nickel change when it forms a nickel ion? So what we have to say here, if we're going to go from nickel which has no charge to nickel which has a 2+ charge, we need to lose electrons, and because it is 2+, we need to lose 2 electrons. That's where your marks are going to come from. Okay, so you need to say it's going to lose 2 electrons. Okay, and there's 2 marks in that answer for yourself. The next one's a calculation. It wants us to calculate the concentration of this solution. So this is my triangle. This is a chicken vindaloo, which is amount, concentration, volume. We're trying to find the concentration. So concentration is amount divided by volume. So that's what we've got written here, amount divided by volume. So the amount is 23.5. The volume is 250, but we divide that by 1,000. And that gives us a final answer of 94 grams, and that is per decimeter cubed as a final response. Okay, and the last little one is it's a really good question. This one tests a lot of the separation techniques. So we've got 2 chemicals reacting together, and it says here that adding an excess of nickel carbonate, so there's more than we need of this, is being added to sulfuric acid. And this means it's going to form nickel sulfate, carbon dioxide, and water. The nickel sulfate is a solution, but describe how we can get dry nickel sulfate from the mixture of nickel sulfate solution and excess solid nickel carbonate in the beaker. So there's a couple of things here they've done to help us. They're telling me that we've got excess of this solid material inside the solution. So visually, when I think about this, this is what I've got in my mind. I've got my solution, which is nickel sulfate, and then here is my excess, the unreacted nickel carbonate. So if I'm going to remove something that is insoluble, because this is just sitting there, it's not reacted, it's insoluble, then the method I would use initially is I would filter. So let me take you through the different stages. We'll zoom in a little bit. So my first job would be to filter, and the filtering means that we remove the unreacted, the insoluble nickel carbonate gets trapped here. The solution will come through. So in the bottom of this beaker, we'll just draw that in the bottom of the beaker here, we have got the nickel sulfate sitting in the bottom, keeps disappearing. Nickel sulfate sitting in the bottom, okay? Then what we can talk about is, once I've got this solution, how do we get the salt, the nickel sulfate, from the solution, from the water? Well, to do that, we'd evaporate, and then we'd allow it to crystallize, let the crystals form. And the evaporation means we remove the water, and we leave the crystals behind when we remove the water. And then once we've got those crystals, we need to get them dry. So to get them dry, we would put the crystals on a piece of filter paper. We put a piece of filter paper over the top, and that would create those dry crystals that we would need to obtain.